Namaste dear children, I am Rekha. Welcome to my channel Rekha's Knowledge Hub. Today we will see NCERT Class 6 Science Chapter 5 Measurement of Length and Motion. Deepa, a curious 11 years old girl, lives in a town of the state of Haryana. The new school year has started. Deepa needs a new uniform since she has grown taller. Her mother takes her to a cloth shop. She asks for a 2-meter cloth piece. The shopkeeper measures the cloth using a metal measuring rod. So here Deepa is an 11-year-old girl. She lives in Haryana. So now the new school year has started. So she needs a new uniform. So her mother takes her to a cloth shop. Then she asks the shopkeeper for a 2-meter cloth piece. Then the shopkeeper measures the cloth using a metal measuring rod. Then the tailor takes her measurements using a flexible measuring tape. Her mother instructs the tailor to increase the length of her uniform by 4 angula, 4 fingers width. Then, after taking the measurement of the cloth, the tailor takes her measurements using a flexible measuring tape. Then her mother instructs the tailor to increase the length of her uniform by 4 angula. 4 angula means 4 fingers width. So in this picture, you can see a flexible measuring tape. This tape can be used to take measurements from our body. Then she has a doubt. Are the tape and rod similar to the scale that the elder sister has in her geometry box? What did mother mean by 4 angula? She has found one scale in her elder sister's geometry box. Is that scale similar to the tape and the rod? So in this picture, you can see the scale. Deepa shares her experience with her school friends Anish, Hardeep, Padma, Tasneem, and this leads to a discussion amongst them. How do we measure? Hardeep says, I have seen my grandmother measuring the cloth by the length of her arm. He has seen his grandmother measuring cloth by length of her arm. In the picture, you can see handspan and cubit. They are non-standard units of measurements. What do you mean by handspan? Handspan is a measure of the distance from the tip of the thumb. See, tip of the thumb to the tip of the little finger with the hand fully extended. That is handspan. Then what do you mean by cubit? Cubit is the distance from the elbow to the tip of the middle finger. That is cubit. These are non-standard units of measurements. Have you ever seen how a farmer measures length to divide his fields into beds? He walks and counts the number of his strides, says Padma. A farmer measures length to divide his field into beds using strides. What do you mean by stride? In this picture, you can see stride. What is a stride? The stride length is the distance between the heel contacts of the same foot. Oh no, just the length of the stride. Sometimes they also use the length of their feet to measure. So in this figure, you can see foot span. What do you mean by foot span? Foot span is a distance between the point of the toe and the heel of the foot. See, this distance is foot span. Deepa says excitedly, measuring length using body parts must be so much fun. Let us also measure something using a body part. What should we measure? Okay, let us measure the length of the table in our classroom, says Tasneem. We can measure the length of the table in our classroom. Padma adds, and which body part should we use to measure it? We have to use which body part? Deepa says, let us use our handspan. We can use our Handspan. Handspan means the distance between the tip of the thumb and the little finger. That is handspan. I will show you how to use it. I have seen my mother using it. She calls it balished. Hardeep adds, okay, let us also note down our measurements. See, in this picture, you can see the use of handspan for measuring distance between the tip of the thumb and the little finger. That is handspan. So, the children measured the length of the table using handspan. See the readings here. Anish got slightly more than 13, Padma 13, then Tasneem slightly less than 13, Deeba between 13 and 14, Hardeep 14. So they got different measurements. Padma says, oh, the number of handspans is different for all of us. Number of handspans is different. So what can we say about the length of the table? But why should the number be different? Hardeep asked thoughtfully. Tasneem says, I can guess. Our handspans are of different sizes. So, handspan of each person is different. Handspan is the distance between the tip of the thumb and the little finger. So, it is different for different people. Anish gives an idea. Let us check this. So all five of them put their handspans along each other and arrive at the conclusion that the lengths of their handspans are different. So length of handspans are different. That is why it is a non-standard measurement. So handspan is not a good method for measuring length because the size of a person's hand varies from person to person. Deepa says thoughtfully, no wonder people use scales and measuring tapes. So handspans, they are different for different persons. That is why people use scales and measuring tapes. Deepa and her friends compare the length of the table with the length of their handspans. The length of the table is expressed in terms of their handspans. Here, the handspan used for measurement is an example of a unit handspan. This handspan is used for measuring length. It is an example of a unit. And the length is expressed in two parts, a number and a unit. So, the length is expressed in two parts. First part is number. Second part is a unit. For example, if the length of the table is found to be 13 handspans, then 13 is the number and handspan is a unit selected for measurement. So, 13 handspans means 13 is the number and handspan is the unit for the measurement. However, handspans and other similar units such as length of hand, foot, fist or fingers differ from person to person. That is important. These units, they differ from person to person. Thus, there is a need for such a unit for which measurements of the same length made by different people do not differ. So we need a standard unit for measurement to make readings more accurate. That means measurement should be same for everybody. Thus there should be uniformity in the measurement. So for the sake of uniformity, we need a common set of units of measurement which are called standard units. India has a rich history of measurement systems dating back to ancient times. Angula, finger width, multiples of angula, dhanusa, and yojana are some of the units mentioned in ancient Indian literature and used in measuring artifacts, architecture, and town planning. So, in ancient India, different types of measurements were used. Angula, that means finger width. Then multiples of angula, dhanusa, yojana. These are some examples. The angula is still used by traditional craft people like carpenters and tailors. This unit is still used, Ankula. It is used by carpenters and tailors. Several objects with ruled markings, which could be scales, have been excavated from sites of the Harappan civilization. Standard units. Several systems of units evolved with time in different parts of the world. However, when people started traveling from one place to another, it created a lot of confusion. This led to the different countries coming together and adopting a set of standard units of measurement. The system of units now used is known as the International System of Units or SI units. Different systems of units evolved with time in different parts of the world. However, when people started traveling from one place to another, it created a lot of confusion. In the case of trade and commerce, these inconsistent units led to misunderstandings and disputes over pricing. So, a lots of confusions arised. This led to the different countries coming together and adopting a set of standard units of measurement. So, different countries, they came together and adopted a set of standard units of measurement. These standard units are called International System of Units or SI units. The SI unit of length is meter. Its symbol is M, that is meter. SI unit of length is meter, represented by symbol M. A meter scale is shown in figure 5.2. See, this is a meter scale. 1 meter is divided into 100 equal divisions. So, 1 meter is divided into 100 equal divisions. Each division is called a centimeter. It is represented as cm. So, 1 meter is equal to 100 centimeter. You may be familiar with a smaller part of the meter scale, typically 15 centimeter long. Your scale is 15 centimeter long. You can see this scale in your geometry box. See, this is a 15 centimeter scale. This scale you can see in your box. Look carefully at the 15 centimeter scale. It has markings in centimeter from 0 to 15. You can see markings from 0 to 15 in centimeters. The length of any section between two consecutive big marks such as 1 and 2 or between 5 and 6 is 1 centimeter. So, between any two consecutive big marks, it is 1 centimeter. See, between 11 and 12, it is 1 centimeter. Likewise, between 6 and 7, it is 1 centimeter. Okay. Observe that these sections of 1 centimeter length are further divided into 10 equal parts. See in this picture, 1 centimeter is further divided into 10 equal divisions. The length of one of these smaller parts is called a millimeter. It is represented as mm. See here, between 0 to 1, you can see 10 equal divisions. Each division is called a millimeter. 1 millimeter. 1 millimeter is the smallest value of length that you can measure using this scale. 1 millimeter is equal to 1/10 of a centimeter. That is 1 millimeter is equal to 0.1 centimeter. So, 1 centimeter is equal to 10 millimeters. 1 millimeter is equal to 1 by 10th of a centimeter. That is 1 divided by 10. That is 0.1 centimeter. So, 1 meter is equal to 100 centimeters. 1 centimeter is equal to 10 millimeter. Would it be convenient to use the unit meter to measure larger lengths such as the length of a railway track between two cities, or to measure smaller lengths such as thickness of a page of book? So, is it convenient to use unit meter to measure larger lengths such as length of a railway track between two cities, or to measure a smaller length such as thickness of a page of book? No. For measuring larger length, we use a larger unit called kilometer, km, which is equal to 1000 meters. So, for measuring larger length, we can use a larger unit such as kilometer. Kilometer is represented as km. So, 1 kilometer is equal to 1000 meters. And for measuring smaller length, we use units such as centimeter or millimeter. So, for measuring larger length, we can use kilometer. And for measuring smaller length, we can use units such as centimeter or millimeter. 1 kilometer is equal to 1000 meter. 1 meter is equal to 100 centimeter. 1 centimeter is equal to 10 millimeter. In some scales, you might have noticed another scale marking. This scale marking is in inches, where 1 inch is equal to 2.54 centimeter. See this scale, you can see inches. Here 1 inch, 2 inch, 3 inch. See, 1 inch is equal to 2.54 centimeter. In earlier days, units such as inch and foot were used to measure length. These units are still used by some people. Suppose we all measure the length of the table again, but this time using a meter scale. Will our results still be different? So, now we can use a meter scale to measure the length of the table. Then, what about the results? Are they different? No. But we should first learn the correct way of using a scale to measure length. We should know how to use a scale to measure length. Correct way of measuring length. For measuring any length, we need an appropriate scale. For example, if you want to measure the length of your pencil, you may use a 15 centimeter scale. If you want to measure the length of your pencil or pen, you can use a 15 centimeter scale. Similarly, if the height of a room is to be measured, you may need a meter scale or a measuring tape. So, if you want to measure the height of a room, then you can use a meter scale or a measuring tape. In this case, 15 centimeter scale cannot be used. You cannot directly measure the girth of a tree or the size of your chest using a meter scale. So, you cannot use a meter scale to measure the size of your chest or the girth of a tree. For such measurements, flexible measuring tape such as Taylor's tape is more suitable. In those cases, you can use Taylor's tape. It is a flexible measuring tape. While measuring length, we need to take care of some points. What is the correct way to place the scale? See picture A. This is the correct way of placing a scale. Place a scale in contact with the object along its length as shown in this figure. Then, picture B. This is the incorrect use of scale. What is the correct position of the eye while reading the scale? For example, if you are trying to measure the length of a pencil, by aligning it with a scale, the position of your eye should be directly above the tip of the pencil. See, suppose you want to measure the length of this pencil, then you can align it with a scale like this. And the position of your eye should be here at point B, that is directly above the tip of the pencil. How to measure the length if the ends of the scale are broken? Suppose if the ends of the scale are broken, then how do you measure the length? If the ends of the scale are broken or zero marking is not clear, it can still be used for measurement. Suppose if the ends of your scale are broken or the zero marking in your scale is not clear, then that scale can still be used for measurement. With such a scale, use any other full mark of the scale. See, if zero marking is not visible, then you can use any other full mark of the scale, say 1 centimeter. See this figure 5.6. Here the zero marking is not there. So, here this 1 centimeter is used. Then you must subtract the reading of this mark from the reading at the other end. Then you have to subtract this reading from the reading at the other end. For example, in figure 5.6, the reading at one end is 1 centimeter. At the other end, what's the reading? It is 10.4 centimeter. Therefore, the length of the object is 10.4 centimeter minus 1 centimeter, that is 9.4 centimeter. So this is the correct method of placing the scale with the broken end. How do visually challenged students measure length? They use scale with the raised markings that can be felt by touching them. So visually challenged students, they use scales with raised markings so that they can felt by touching them. Activity. Select some objects around you such as a comb, pen, a pencil and an eraser to measure their length. Measure their length one by one using a meter scale and note down the measurements in table 5.2. So a table is given. We have to measure some objects and write the length of the object. See, pencil 12 centimeter. Centimeter is a unit. 12 centimeter. Then eraser 3 centimeter. Pen 13 centimeter. Like that you can write. While writing the length, do not forget to write the unit also. So, while writing the length, you have to write the unit. If it is 13 centimeter, you have to write 13 cm. Thus, your result will consist of two parts. One part is the number and the other part is the unit of the measurement. So, your measurement will consist of two parts. One part is the number and the other part is the unit of measurement. Some of your friends in the class would have measured the length of the same objects. Compare the length measured by you with that of your friends. Are the measured length the same or slightly different? If not the same, discuss the possible reasons for the differences. So you can compare your measurements with your friends' measurements. Why are some length measuring devices made up of flexible materials? Some length measuring devices are made up of flexible materials. Why? Because flexible materials are suitable for measuring objects that are not perfectly straight. Also, they are easier to carry around and store. They are often easier to handle, especially for young children. Units of length such as kilometer, meter, centimeter and millimeter begin with a lowercase letter except at the beginning of a sentence. See, K is a small letter, M is a small letter, C is a small letter. Here, millimeter, M is also a small letter. So, these units begin with a lowercase letter except at the beginning of a sentence. Their symbols km, m, cm and mm are also written in lowercase letters and are never followed by s for the plural. They are not followed by s for the plural. Note that a full stop is not written after the symbol. There is no need of full stop except at the end of a sentence. If it is at the end of a sentence, you can put a full stop. While writing the length, always leave a space between the number and the unit. If it is 13 centimeter, you write 13, then leave a space and then write cm. Measuring the length of a curved line. Anish and his parents fixed electric string lights on the arches of the veranda of their house for a celebration at home. How would they have measured the required length of string lights? In the case of a curved line, measurements can be made with the help of a flexible measuring tape or by using a thread as shown in figure. So, if you want to measure the length of a curved line, then you can use a flexible measuring tape or you can use a thread like this. You can see in this picture how to use a thread to measure the curved line. See, you can keep the thread like this. The thread can then be straightened and its length can be measured using a meter scale. So, after measuring the length as in this picture, then the thread can then be straightened and its length can be measured using a meter scale. Describing position. One day the teacher informs her students that she has planned an educational visit to a nearby garden. So one day the teacher informed her students that she had planned an educational visit to a nearby garden. She asked the students to reach there directly in the morning. She asked the students to reach the garden directly. Deepa and her friends start discussing whether the garden would be closer than their school or farther. Tasneem and Padma say that the garden would be closer, while Deepa and Anish feel that the school would be closer. Hardeep thinks that both would be almost at an equal distance. So, for some children, garden will be closer, but for some other children, school will be closer to their house. Okay. For some children, both school and garden will be at equal distance. See this picture here. See, here you can see a bus stand, then school. This is a school, then Deepa's house, Anish house, Hardeep's house, Tasneem's house, Padma's house. Then here is the garden. So for Padma, garden will be closer when compared to school. For Tasneem also garden will be closer. But for Deepa and Anish, school will be closer to their homes. Okay. Then what about Hardeep? For Hardeep, both garden and school would be almost at an equal distance. Who do you think is correct? All of them are correct. Then why are their observations different? They are locating the distances of the school and garden from their houses. They are locating the distances of the garden and the school from their houses. If instead each of them had thought of distances from a same object or point, say the bus stand, then their observations would have been the same. See, if they are using the bus stand instead of their houses, then their observations would be same. When distance is stated with respect to a fixed object or point, then this is called a reference point. So, when the distance is stated with respect to a fixed object or a point, then that point is called reference point. A few days later, Hardeep tells his friends excitedly, "Let us all go to the playground. The sports teacher wants us to help her to draw lines with the chuna powder, limestone powder for making the kabaddi court for the sports day." So, one day, Hardeep told his friends that their sports teacher wanted to help her to draw lines with limestone powder for making the kabaddi court. "Padma, we will need a longer measuring tape. Let us take it from the sports room." So Padma said, "We need a longer measuring tape. We can take it from sports room." Then Deepa said, "Let us first decide the point on the ground from which we will measure the distance to start drawing the lines. Let us call this our reference point." So Deepa said, "First we can find out the reference point from which we can start drawing the lines." See this picture, drawing lines for kabaddi court. Here, a point is used as the reference point. From there, the children started drawing lines. After a few days, Padma was traveling by bus to visit her grandparents in Delhi. She was eager to reach Delhi and was reading the kilometer stones on the side of the road. On one of the kilometer stones, it was written Delhi 70 kilometer. Further on, the next kilometer stone read Delhi 60 kilometer. Each kilometer stone indicated to her that she was getting closer to her grandparents' house. So when Padma was traveling by bus to Delhi, she saw many kilometer stones. First, she saw a kilometer stone like this, Delhi 70 kilometer. Then further, she saw a kilometer stone, Delhi 60 kilometer. So each kilometer stone indicated to her that she was getting closer to her grandparents' house. These kilometer stones indicated her distance from Delhi. So Delhi is a reference point in this situation. So here Delhi is the reference point. So kilometer stones are markers placed along roads at regular intervals to indicate the distance from a specific point. What do such kilometer stones indicate? How could Padma conclude that she was getting closer to her destination? So these are the positions of kilometer stones with respect to Delhi as a reference point. See, here Delhi is a reference point. At first it is Delhi 70 kilometer. Okay. So Delhi 70 kilometer means Delhi is 70 kilometer away. When you travel further, you can see like this. Delhi 60 kilometer, then Delhi 50 kilometer, Delhi 40 kilometer, then 30 kilometer, 20, 10, then 0 kilometer. When you reach Delhi, it will be 0 kilometer. If the kilometer stone reads Delhi 70 kilometer as shown in figure, we can say that the position of Padma is 70 kilometer from Delhi. So, if Delhi 70 kilometer stone is found, then Padma is 70 kilometer from Delhi. When the kilometer stone reads Delhi 60 kilometer, the position of Padma is at 60 kilometer from Delhi. That is, she is getting more closer to Delhi. Does this mean that the position of Padma with respect to the reference point is changing with the time? When does the position of an object change with respect to a reference point? Does it change when an object is moving? Moving things. Activity. Let us explore. Look around and prepare a list of 5 objects that are in motion and 5 objects that are at rest. So you have to prepare a list of 5 objects that are in motion, and also you have to prepare a list of 5 objects that are at rest. Record your observations in table 5.3. Think about how you decided whether an object was in motion or at rest. How do you decide whether an object was in motion or at rest? Write your explanation or justification in table 5.3. Compare and analyze your justifications. How can one decide if an object is in motion or at rest? An object is said to be in motion if its position changes with respect to the reference point with time. So, an object is said to be in motion if its position changes with respect to the reference point with time. If an object is not changing its position with respect to the reference point with time, it is said to be at rest. So, an object is said to be in motion if it is changing its position relative to a fixed point. This means that the object is moving from one place to another. On the other hand, an object is said to be at rest if it is not changing its position relative to a fixed point. This means that the object is staying in the same place. It is important to note that whether an object is in motion or at rest, it depends on the reference point you choose. For example, a person sitting on a train may appear to be at rest to someone sitting next to them, but they are in motion related to someone standing on the platform. Observing things around you. Objects in motion, justification. Objects at rest, justification. See, objects in motion. Cow grazing in the field is in motion. Cow changes its position while grazing. That is a justification. Then objects at rest. For example, tree. Tree remains in the same position. The next one, moving car. A car driving down the road is in motion related to the ground. Then a train on the track is in motion. Train is moving from one place to another. Then a runner. Person is moving from one place to another. Then planet. Planet is revolving around the sun. Satellite moving around the planet. So these objects are in motion. Then we can see objects at rest. Tree remains in the same position. Then parked car. The car is stationary in a parking lot. A chair. Chair is not changing position. House. House is fixed in its location. Book on the table. Book remains still until someone picks it up. Then a statue. Statue is fixed in its position. Deepa looked around her in the bus and noticed that all the passengers were seated. She looked around again after a minute and found them still occupying their seats. She wondered, are they moving? She concluded that the position of the passengers was not changing with time. Therefore, they were certainly at rest. However, when she looked outside, she felt they were in motion as their positions were changing with respect to things outside. So, when she considered herself or the bus as a reference point, the passengers were not moving. But when she considered an object outside the bus as a reference point, the passengers were moving. So the reference point is important in deciding whether an object is at rest or in motion. If Deepa considered herself or the bus as a reference point, then passengers were at rest. However, if she considered any object outside the bus, say a building, as a reference point, then the passengers and the bus were in motion. So, the reference point is very important in deciding whether an object is at rest or in motion. Suppose you are traveling on a ship which is moving at a constant speed along a straight line on a calm sea. Suppose there is no window on the ship. Is there any way that you can determine whether the ship is moving or is stationary? No, it is not possible to determine whether the ship is moving or is stationary without any external reference. Because here the ship is moving at a constant speed, then the sea is very calm and there is no windows on the ship. So we need an external reference to determine whether the ship is moving or is stationary. Children, if you like this video, please like, share and subscribe. We will see in the next video. Thank you.